Here I want to start talking about different operations that we can perform on rational expressions. And we're going to work on multiplying in this video. So I'm going to go back to just basic fractions first. So think about your basic fractions. Let's say I had something like 1/5 times 10 over 4. Well, what we do here is we end up multiplying straight across and then also still canceling and simplifying any factors in common. So this is going to be 1 times 10 over 5 times 4. Now you can multiply across and then simplify at the end, although you can also simplify first. So one thing to note here is that you could actually break this 10 down into 5 times 2. And then we can cancel out those common factors still. Here we also have a 2 over 4 that can cancel. So let's break that down again. So 1 times 2 is 2 over 4. But again, here I have a 2, and then 4 is also 2 times 2. So again, I can just keep canceling those factors and simplifying what's in common. If you do have nothing left, there is always a factor of 1 there. So my final answer would be 1/2. So when you're multiplying fractions, the overall idea is that we stay straight across. Everything gets multiplied straight across, and then we're just canceling factors in common like we did with simplifying. And we're going to use that same strategy here for rationals. Now, a little tip here is that I do recommend factoring first. When you multiply straight across, you actually don't want to FOIL everything up because we do want to factor to cancel things in common, like we did here. We started breaking those numbers back down. So I do recommend, again, try to factor first. Is actually going to be a little bit more helpful for you. So this first polynomial has nothing to factor. There's no common or no GCF to really take out, just 1, and there's no squares. But for this one here, I can factor this. X squared minus 1 is x plus 1, x minus 1. And then I do have a GCF of 3, so a common value of 3 here that I can factor out, and I have x minus 7. Now remember that you multiply just straight across. So all I like to do is I like to rewrite this. So I have an x minus 7 from the first group. I am going to put that in parentheses because it does need to stay together. It's one factor. Here I have an x minus 1 from the x minus 1 from the first group, and then a 3 and an x minus 7. And I like to just rewrite it for myself, and now I start canceling what's in common. So I have an x minus 7. I have an x minus 1. So x plus 1 over 3 is going to be my final result here. Okay, so my big thing is that I'm going to start factoring everything. Again, it usually helps to factor first, just makes it a little bit easier. And then for multiplying, you're just rewriting everything straight across and canceling those factors in common. So here is my final result. Okay. Now, when you're doing domain, though, again, you do have to be careful. Now I know at the end, I only have a 3 in the denominator, so I don't have to worry about the denominator being 0 here, but that wasn't my original problem. My original problem did have 2 denominators, right? So I do need to make sure that these original denominators are also not 0. So I need to make sure that x minus 1 is not equal to 0 and 3x minus 21 is not equal to 0. So here you're just adding 1 to both sides. Here we can add 21 and then divide by 3. And even though we don't see it at the end of the problem, there are 2 values we do have to exclude here if we were to plug in and evaluate. And they would be the values of 1 and 7. So we're going to exclude, I'm just going to write the set notation this time, those 2 values here for my domain. So again, I'm just going to keep reminding you when you're checking rational expressions, watch those denominators, but you also have to check the original ones too, not just the ending result. All right, let's do another example. Okay. So here's another example. We're multiplying. So we're multiplying those two expressions. And again, I'm going to start by factoring here. So x plus 3, I can't do anything with. But x squared minus 4, I can break into x plus 2, x minus 2. Here, I'm going to try to factor this as well. So let's see, minus 3 and positive 2 is going to work there. And then I'm going to factor here too. And plus 3 and plus 3 is going to work for my factoring there. Now I like to just rewrite everything. Remember, this stays together, so I'm going to put parentheses there, and I go straight across. And then I'm going to start canceling. So here I have an x plus 3 and an x plus 3. Be careful, I can only cancel one at a time, so this one has to stay. Here I have an x plus 2, x plus 2. So let's see, I'm left with x minus 3 up top, and then an x minus 2 and an x plus 3 in my denominator. Now, I will say that often with rational expressions, you can leave it in factored form rather than multiplying everything back out. So as you're doing your question, just read the problem. How do they want their answer? If they say that you can leave it in factored form, then you can leave it like this. This is very common with rational expressions, that we often just leave everything factored in the final result. So I'm going to leave my answer like this. If I'm checking my domain, though, I am going to be careful. So at the end, I do have two domain issues here, right? I can see two right here. X minus 2 cannot equal 0, and then also x plus 3 cannot equal 0. So right away, I can see that I need to exclude the value 2, and I also need to exclude the value negative 3 if I solve those two equations. I do need to check, though, make sure I haven't missed anything from the previous starting values here, right? So if I go back to my originals here, I had x squared minus 4 could not be 0. And that factored into two parts. So that factored into x plus 2, x minus 2. And you do see here that we are missing one of the groups, right? I had the x minus 2 in my answer. So I knew that one already. I can't let x be 2, but I missed this one. So x can also not be negative 2. So I have one value here, and now a new value here that we missed in the original. And then you'd also want to check this as well. So if I think about x squared plus 6, I'm just going to go right here. X plus 9, I'm going to make sure that's not 0. But we already saw that that factored into x plus 3, x plus 3. And we actually do have this result already, right? We did include this one. Since it's the same, they're both going to give you another value of negative 3. So there's nothing new there that I've missed. So there are 3 values altogether that I need to exclude from my domain. And again, I'm just going to use set notation to save a little room here. So x cannot be negative 2, positive 2, or negative 3. So just be careful when you're checking. Make sure you check your end result, but also make sure you check your starting problem, because you may have canceled a factor out, and there could be something there that you need to exclude for a value.